Welcome to Summarize Science. Have you ever wished you could record a dream or show someone an image that's only in your head? It sounds like science fiction, but researchers are getting closer than ever to making it a reality. This paper introduces a new AI model called HAVIR, which stands for Hierarchical Vision to Image Reconstruction. Essentially, it's designed to reconstruct the images a person is looking at just by scanning their brain activity. Now, scientists have been trying to do this for a while, but previous methods really struggled. They could often get a blurry, vague idea of an image, but they failed when scenes got complex. Think about a busy street, a cluttered room, or a field of flowers. These were almost impossible to reconstruct accurately. The old AIs couldn't figure out both the fine details and the overall meaning at the same time. So, what makes this new HAVIR model different? The researchers took inspiration directly from how our own brains process vision. Our brain doesn't just see an image all at once, it processes it in stages, in different areas. HAVIR mimics this by splitting the task into two parts, as you can see in this diagram. One part of the AI, the structural generator, acts like a sketch artist. It looks at brain signals from the early visual cortex to figure out the basic shapes, layout, and structure of the scene. The other part, the semantic extractor, is like a concept artist. It analyzes signals from higher-level brain regions to understand the meaning of what's being seen. Is it a car, a person, a building? Then, a powerful AI image generator takes the basic sketch and the conceptual meaning and combines them to create the final, detailed picture. And the results are pretty incredible. Take a look at these examples. On the left, you can see the original image the person was shown, and on the right are the reconstructions from different subjects' brain scans. Look at how it captures not just the objects, like the cars and people, but also the atmosphere, like the wet street in the rain or the dim lighting of a room. When you compare HAVIR to other recent methods, the difference is clear. In these examples, you can see that other AIs struggle with the color of the flowers or the details of the clock face. HAVIR, however, does a much better job at capturing both the structure and the correct semantic details, like the pink color of the flowers. And it's not just a matter of opinion. The researchers used several metrics to scientifically measure the accuracy of the reconstructions. Across the board, HAVIR either won or was a top performer, proving its superiority in a quantifiable way. So, let's recap the breakthrough here. By mimicking the brain's own hierarchical process, separating the what from the where, the HAVIR model can decode complex visual scenes from brain activity with stunning accuracy. This is a huge leap forward in the field of neural decoding. What could this mean for the future? In the long term, technologies like this could be life-changing. Imagine being able to communicate for people who have lost the ability to speak, or creating new forms of art straight from the imagination. It could even one day help us understand the mysterious world of our dreams. It's a fascinating step towards bridging the gap between mind and machine.